Hey everybody, welcome to lesson 2.2 on how to solve a two-step equation. We're going to first start off by solving some two-step equations in our head, and you're going to see how easy this is. Here's our first one. This is an equation because there's an equal sign. And we know that if there's an equal sign here, that this side is the same as this side. So if this side of the equation is 15, that means this side of the equation has to also be 15. So you see a blue box here. What I want you to do is think about what number would this blue box represent that would make this equation true. Yes, a 12. But what if I told you that behind the blue box was a 2x? You told me the value had to be 12, so what would the x have to be in order to make it 12? You're right, 6. You just solved this two-step equation in your head. This is called the cover trick, where you can cover this up and try and determine what that missing value is. Try this one. If this side is 8, then this side also has to have a value of 8. So what's the value of the blue box? You're right, it's 9. But what if I told you that 3x was behind it? What would the x have to be in order to make this 9? You got it. X equals 3. Again, a two-step equation, and you were able to figure it out. But how do you show your work? Because we need to be able to show our work of the steps that we're doing in order to get our answer. Especially when the equations get really tough, it's hard to keep it all up in our head. So these are the two equations that you just solved. We know the answer is 6 here, and we know the answer is 3 here. So how do you work that out and actually show the algebra, right? Well, I'm going to draw a line right down the center of this equal sign so that whatever I do to one side of my equation, I see that I also do it to the other side. It's just going to help me balance my work a little bit. Now, I like to usually tell a story about a party when I solve equations. You are the variable, you are the x. And what two kinds of people are at your party? Well, generally when you have a party, you invite your best friends, your closest friends, and then you also invite some acquaintances, people that you just know that you kind of say hi to in the hallways. But those two different kind of people, right? So if you're the x, so you're the variable, you're the x right here. Do you see how you're stuck right here to this 2? Those are your closest friends, because at your party, you're going to be hanging really close to your best friend. So there's your closest friends. These other 3 people, those are just the acquaintances. So think about now, if your mom or dad come down and tell you got to send some people home from the party, who would you send home first? Well, obviously your acquaintances. So let's undo this +3, those guys hanging out over there with the inverse operation. -3 to both sides. I have 2x. Remember, you are the x. 15 minus 3 is 12. Now, there I am hanging out with my 2 closest friends. Dad's come down and says, you got to send everybody home, so I got to send these guys home. How? Division, the inverse operation. So I divide both sides by 2, I send those guys home, and I get x equals 6. So this would be showing my steps in order to solve. I show those 2 steps, the subtracting by 3 and then the dividing by 2. Over here, a little different. Here I got the x connected to the 3, so this looks like I've got 3 closest friends at my party, and I got 1 acquaintance. So if I had to choose to send somebody home from the party first, it would be the acquaintances. I'm going to do that using the inverse operation. I'm going to add 1 because that's subtract 1. Cancels. Here I get 9. Over here I get 3x. Then I got to send these guys home when it's the end of the party. Send them on home with division, the inverse of multiply, dividing by 3. I just have me, myself, and I left at the party. And 9 divided by 3 is 3. So here I showed my step of adding 1 to both sides and dividing by 3 to both sides. So two-step equation, I should see 2 steps in your work. Okay, so let's give some a try. They're just the answers all worked out and pretty. All right, we're going to look through examples 1 through 7 here together. You will need a calculator once we get to the word problem at the very end. So here's our first example. Go ahead and write it down if it's not already written down in your notes. So our goal is to be able to figure out what number divided by 2, take away 3, gives us the same value as 5. So I'm going to first start off by using the cover trick. The n divided by 2, that's stuck together. I'm just going to cover it with my hand here. And I want to just ask you, what number minus 3 would give you 5? And you would probably say, well, Mrs. Johnson, that number behind your hand here, that would be an 8. 8 minus 3 would be 5. So if I told you that this right here, you said this has to represent an 8. You see how that works? 8 minus 3. Okay, so if that represents an 8, what would the n have to be to make this an 8? 16. So right now, I know the answer to n is 16. 16 divided by 2 is 8, and 8 minus 3 is 5. So I just did it in my head with that little cover trick, kind of like I did at the beginning of this with the little blue boxes. Okay, so let's algebraically figure out how to get this answer. I'm going to draw a line down the middle here. N is the goal I want to get by itself, so I'm just going to put a box around it. So it's connected to the 2. Those are our closest friends. It's connected with division. Leave them alone. Let's send home the acquaintances. So right here, the minus 3. Let's add 3. So I got n divided by 2 equals 8. So my goal is to get the n by itself. I'm going to send these guys home now. Do you see how they're divided by 2? I want to multiply. Multiply by 2 here, multiply by 2 here, both sides, and I get n equals 16. So this is my work. I can see my 2 steps. I added 3 to both sides, and then I multiplied 2 to both sides. Let's try the next one, number 2. So here we've got 2/3 times x minus 4 equals negative 14. Here we're going to have a fraction. So we're going to be kind of pulling back what we learned the other day with fractions. Okay. Oh, that marker doesn't work. I guess I'll use blue. Okay, so here I am. I'm locating myself. I'm the x. I'm connected to 2/3 of a closest friend. Imagine that. All right, these guys are going to stay at the party. I'm going to first have to send home acquaintances so when it starts getting late. So let's undo this with adding 4. I have 2/3 times x equals negative 14 plus 4, negative 10. Okay, now I'm ready for my second step. Now, over here, I see my x is multiplied by a fraction. And in order for us to undo the fraction, we're going to multiply by the reciprocal. So multiplying by 3/2, this side and this side. So 3 cancels with 3, 2 with 2, and I get x equals... Now over here, this becomes 10 over 1, and I simplify before I multiply. Do you see the 10 and 2? Both divisible by 2. Divide by 2, I get 1. Divide this by 2, I get 5. Don't forget that's negative 5 times 3, negative 15. So there we have. If I put that back up here, 2/3 of negative 15 minus 4 equals negative 10. And 2/3 of negative 15 would be negative 10. That would work out. So want to be sure that I can see your steps in your work. 2-step equations, going to have about 2 steps. Let's try 3. In fact, I'm going to write 3 up here twice, just because I'm going to show you 2 different ways of doing this. You watched a video on 1-step equations the other day. I told you that you could fast forward to number 6 because they kind of show it a different, unique way. And I'm going to show you that today. So here, how did you maybe learn to do this last year? Let's see. See the t? Ah, there's a number 1 in front of that, isn't there? There's a 1t. That's your closest friend. Well, you only got 1 friend. All right, so we're going to send home acquaintances. So I'd want to get rid of the 8. A lot of kids will say they want to add the 8. But think about if I added 8, don't I just make 16? I can't cross that off. No way. That's a positive 8, so I'm going to have to take away 8. 8 take away 8, that's 0. Take away 8 on this side. Now, careful when you bring down. All of this has to come down. The negative t. It's going to make it easier if you put a 1 in front of it so you can actually see that that's what you have to undo and get rid of. Over here, I've got negative 3 take away 8, which is negative 11. Not done yet because I'm solving for t, not negative 1t. So here I see that this is multiplied together, so I want to undo it with division. Divide by negative 1, and I get t is equal to positive 11. So let's go back up and check it. 11. 8 subtract 11. If the t here is the number 11, does that make the equation true? 8 minus 11 equals negative 3. Yes, it sure does. It makes it true. Now I'm going to show you a different way of looking at this. Kind of like this better. My first step over here was to undo the 8, but instead on this side I'm actually going to undo the t. This says take away t. I'm going to add the t to both sides. Negative 1t plus 1t, they cancel. They're opposites. I just did the inverse operation on the t. So I'm going to bring down the 8. Now I have negative 3 plus t. Okay, remember my goal is to get the t by itself. So I'd have to undo this negative 3 by adding 3. 11 equals t. What happens here is I avoid all the negative, just a different way to look at the problem. Okay, so this could potentially be something that maybe you'd like to try when you get to something like this. I just want to show you a different way of looking at it. All right, on 4. Haven't seen many equations that look like that, maybe a little bit in 7th grade. We have what number take away 2 divided by 4 is equal to 6. Let's cover this up. I'm going to just take this eraser right here. I'm just going to cover up the x minus 2, that expression. What number divided by 4 is equal to 6? Well, I bet you say 24. 24 divided by 4 is 6. Well, that means that this right here has to be 24. So if this right here is 24, what would the x have to be to make it 24? Aha, 26. So right now, I know that x equals 26. If I put a 26 in here, this would become 24. 24 divided by 4 is 6. So just by plugging in that value in for x, I can tell that it's true. But how do we get it with algebra? Okay, I'm going to back this up. Ooh. Oh, I guess I thought I had that on click. Never mind. Okay, well, on here, on this one, I want to kind of keep that x minus 2 together. I know this doesn't really follow the rules, and it doesn't even follow the party scenario. But up here, this x minus 2, it's kind of like stuck together here with that subtraction sign. I actually want to undo that last. So I want to get rid of this divide by 4 first. Let's get rid of that denominator. How? The inverse operation of divide. Let's start by multiplying by 4. Get my line here. I'm going to multiply this side by 4 also. Cancel, cancel, and I'm going to bring this down. X minus 2. Okay, now let's get the x by itself. So now we're going to send home these minus 2 with adding. And that's how I'm going to get the 26. So it doesn't really follow the rules that much, but they can be a little tricky when they look like that as a fraction, when you have that x minus 2, but we want to keep that together. In fact, let's try another one like that. See? Look, I have that on a click now. I don't know why it wasn't working before. Okay, so we have n plus 7 divided by 3 equals negative 4. Of course, you could try the cover trick. You could cover it up and just try and decide what number would that have to be. You could do that for sure. Let's just solve it. So when I see this, I see n plus 7 up here. I want you to think that this is almost like in parentheses. These are going to stay together. The n plus 7 stays together. We've got to get rid of the denominator first. So imagine that as staying together, kind of a little box. Let's first undo the divide by 3. We're going to multiply by 3. Cancel here, and I'm going to bring down the n plus 7. Over here on this side, signs disagree, negative 12. So my goal is to get the n by itself. I want to minus the 7, send home these guys. Negative 12 minus 7 is negative 19. Negative 19 equals n. Now check your answer. So if I go back up into the original equation and I plug in negative 19 for n right here, negative 19. So negative 19 plus 7. This right here would give me a value of negative 12. Is negative 12 divided by 3 equal to negative 4? Yes. So plug it in and check it. Then you know that your work is correct. Okay, one last one before we get to the word problem. I put this one in here for a reason because it's going to kind of, there's a few little silly mistakes that kids will make when it comes to a problem like this, and also it's going to give us kind of a different answer. So getting it copied down here, we're going to draw a line. You are the variable, you are the C. Looks like you're connected to 5 closest friends. These are the acquaintances. So Dad comes down and says we got to send some people home. We're going to send these guys home. Careful though. A lot of kids see this minus sign right here and immediately think, well, I'm going to have to add. I have to do the opposite, add. But no. 15 plus 15, that's 30. We want it to be 0. We're going to get rid of. This is a positive 15. We don't see the plus sign in front of it, but it's positive. So we want to actually take away or subtract. 15 minus 15 will give us 0, and we can cross it off. Same thing over here. So now, careful, when you bring all this down, the negative has to come with it. Negative 5c, and then here we have 12. Okay. Now we're multiplying. Negative 5 stuck to c, that's multiply, so the inverse operation would be to divide. I want to divide by not just 5. I got 5 closest friends with a bad attitude here, right? You got to send them home with their bad attitude. Divide by negative 5. Negative 5 divided by negative 5 gives you positive 1c. Over here, negative 5. Okay, now do you see 12 is not divisible by 5? So in this case, it's just showing you that you're not always going to get a perfect whole number or integer for your answer. We may get an improper fraction. And you can just leave it as negative 12 fifths. Or, you could always change it to a mixed number, but it's not necessary. So sometimes you're going to get something that's not exactly perfect, nice answer. Okay. All right, now we're on to setting up an equation for a real life problem with 2 steps. The other day we did it with a 1-step equation. Now we're going to look at it with 2 steps. So here we have a school selling granola bars to raise money. We got some granola bars. They purchased 1,250 granola bars and they paid a delivery fee of $25. The total cost for everything, including the delivery fee, was $800. We are asked what was the cost of each granola bar. So think, what are we being asked? The cost of the granola bar. So we're going to write an equation, but we need to define a variable. What are we solving for? We're solving for the cost of the granola bar. So maybe we could use C to represent the cost of the granola bar. Okay, so that's the variable we're going to put in our equation, cost. So there's two things we're paying for. We're paying for the granola bars and we're paying for a delivery fee, right? So sometimes I like to use this blank line strategy. We're paying for two things. The granola bars plus the delivery fee equals the total amount of money that I'm spending, okay? I know the total amount of money was $800, so we're going to put that here. Now, do I know the cost of the granola bars and the delivery fee? Yes. The delivery fee is a one-time fee I pay of $25. However, the cost of the granola bars, this is how many granola bars there were, but they each costed a certain amount of money. So think, what expression would we write for the cost of the granola bars? Well, we have 1,250 granola bars times the cost of each of them, right? Like if they're each 50 cents, I multiply it by 50. If they're each $1, I multiply it by $1, right? So now we have an equation. The cost of the granola bars plus the cost of the delivery fee equals the total cost of everything. Now our goal is to solve for the C. How many granola bars, what was the cost of each granola bar? Well, just looking at this, when you think about, even if we took the C out, you see how these two numbers would add to be something bigger than 800? So this is going to be under $1. It's going to be a decimal to make this value smaller. So I already know that. I'm going to need a calculator for this. All right, so let's start off by sending home acquaintances. Really what we're doing is we're just taking away the delivery fee. So let's take that away, times C. We got now $775. So this is just telling us that the granola bar cost was $775, right? Because we took the delivery fee away. This is what we actually paid for the granola bars. Now let's figure out what they each cost. So here, this is multiply by C. I want to undo it by dividing. And then dividing this side also. So really what I'm doing is I'm taking the cost, the total cost, and dividing it by all the granola bars. And you can see here how this is going to be a decimal. So if you got a calculator, you can do it too. My calculator is saying 0.62. So 62 cents for the cost of each granola bar. And I can go back and I can plug it back in here. 1,250 times 62 cents plus the $25 delivery fee to see that it equals the 800. Okay, so that's how we would set up a two-step equation. I would suggest drawing blank lines, thinking about what do I pay for? This plus this plus this equals the total. Okay, it just is helpful, and then you always should define your variable before you start off. Thank you so much for joining me for lesson 2.2. Happy practicing!